Today, as Brian said, we are going to talk about software estimating and how to improve those estimates with a particular focus on the idea of psychology and biases, human nature, which I think makes it very, very interesting. And as every good tech presentation probably needs, you need a reference to Dilbert. What's interesting, if you're not familiar, the software industry is historically pretty bad at delivering software products on time and on budget as an industry over time. In some of there's a chaos, it's called the chaos report out there. It's a Standish group that's produced every couple of years. The last one I saw was 2020. But that said, 66% of projects end in partial or total failure. 31% of projects canceled. 17% go so bad they threaten the life of the company. In 52, a little over half of software projects will cost about 200% more than their original estimate. And I think there's a lot of factors that go into that beyond estimating, but that's a core concept. If we can estimate better and figure out what we need to do and what we can create, I think the better off we'll be. Some other more recent stats, 40 to 50% software projects are delivered late, 78% projects experience scope creep, which often leads to that project failure. So in addition to talking to some of these biases and ways to approach those, some other ways to talk about software estimates that we'll dive into to help sort of change the conversation as I think about it. And one of the things that's happened in my career, having entered the software world 30 years ago, we very much focused on traditional waterfall software development at the beginning. And that definitely leads to project failure. So, 20 odd years ago, the agile movement started, and we have as an industry gotten better. So whereas, 13% of projects were considered successful from a waterfall perspective, 42 are now considered successful. And from an agile perspective, still not a really good track rate. So how can we do better? And one of the things as I reflect on those 30 years and had some recent travel, I in my discussions with customers, clients, I think about software in terms of construction, particularly as people new to software and customers that aren't familiar with the software development process. There's a lot of analogies to the world of software, of construction, of building physical businesses. There are lots of differences as well, but there's some analogies that you can make pretty closely. And pyramids were developed, thousands and thousands of years. But in that same time frame of 4,000, 5,000 years ago, this I was actually in Greece recently, and this is a picture I took of a Minoan civilization, some of the earliest civilizations on the island of Crete, 4,000, 5,000 years ago, and they were building windows and understood the principles of, hey, this is a weak point in the window, so let's put extra blocks around it. But interestingly, here you also see gutters. You need to get the rainwater off the roof. So we've been building and constructing things for a long time. What's interesting about that very thing, estimates are a huge part of construction. And KPMG did a recent survey, 86% of construction projects exceed their initial estimates and cost an average of 28% more. 31% of projects came within 10%. So something that we as humans have been doing for millennium. We're probably a little better than software, but still definitely challenged in terms of coming up with estimates. So yeah, you look at this in terms of human experience, physical construction for a millennium, software development only decades now. So how do we do better, and why are we challenged by this in terms of construction and even software development? There are definitely, for every project, unique project characteristics, unforeseen, site conditions. Parents years ago built a house in a neighborhood and they found a large boulder, that required dynamite to extract it. Nobody expected that to be there, but cost time delays and extra costs and things like that just were unanticipated. Design changes and scope creep will always impact development efforts. External factors beyond our control, complexity, and interdependencies. So why do estimates go wrong? Interestingly, it's called Hofstadter's law. It always takes longer than you expect, even when you take this into account. Douglas Hofstadter was a very famous software developer way back in the 70s. And he came up with this, and I think this is still very much true today as it was 50 odd years ago. A big part of software estimates and our lack of ability to do a good job of them is human nature. And I'm going to focus and talk about each of these biases and ideas and what their impact is on software development. And this goes beyond software development estimates and just probably life in general, basic psychology. So we'll look at each of these in some detail. The first is the optimism bias, and its tendency for stakeholders to be overly optimistic about your timelines and costs. It causes us to be optimistic. We think we know and understand what's going on, that we are in control of everything. And part of it is a selective memory, remembering, the good things in the past. It's like, hey, we did this project and we did pretty good at it, and apply that. So, I think it's a good thing that we are optimistic, but it does tend to bias us and not consider all of the factors. And there's this is called the Dunning-Kruger effect. When people with limited competence in a particular domain, they very much in this optimism tend to overestimate their abilities. So, if we look in terms of knowledge and confidence level, that early on in your career or even in a particular domain space, you don't have all of the knowledge that you'll have, several years from now. So you're going to overestimate. You're going to be optimistic about your abilities to figure that out. Over time, you'll realize, okay, there's a lot that I don't know, don't understand, and then you'll start gaining that knowledge and experience over time. So definitely something that is not new, but impacts our ability from an optimism perspective to generate good software estimates. The second one is a uniqueness bias, where we perceive circumstances or experience a project as more unique and exceptional as they are. So we do tend to do similar projects over time, and we're going to overemphasize those differences. Why is this not like the other? So it makes us discount, past experience, prior experience. And, we also have a tendency to want to reinvent the wheel, like, oh, I can do this better than I did last time, which may be true as you're gaining experience and knowledge, but you really do need to look back and understand, okay, we had, this experience on this project and this is what happened. And it's not as unique as we may think. One of the things that's interesting in this is the idea of uniqueness often impacts experts' ability in their own perceptions. Because they are experts in the field, they can have an overconfidence based on this, and that they think their uniqueness, so sort of a different spin on this, because that they're an expert in their unique capabilities, give them a leg up, and that is true, but it's an overconfidence that can cause problems with your software estimates. Also, likewise, as more senior people are doing estimates, and then maybe those tasks are handed off to more junior people within the project team, you have to take that into account. So where I have 30 years of experience, I might be able to do a task in 2 or 3 days because of that experience. Someone that is newer, might take them a week to do. The hindsight bias, this has a number of impacts, not only in software estimate, but just across the board. It's after something occurs, our memory as humans is very fallible. We don't really remember things accurately. We tend to shape events after the fact. So you have to be really careful of this hindsight. It's going to distort your memory, help you become overconfident. So you're going to go into, oh, I knew that all along, but did you really? So being aware of this hindsight, you may have heard the phrase, hindsight is 20/20. It's always obvious after the fact that you can better understand it. And this also comes into as you're, in retrospectives, examining how well you did in a project and looking back. It's very easy to do that and apply that 20/20 hindsight vision of that. We did know this. We should have done better. But you have to really think about and understand what was known at the time. So how do you avoid that hindsight bias? Along a similar track and related to the concept of that fact that our memory is fallible, we tend to rely on those things that are more easy to remember. And we have a tendency to remember the things that have gone better than worse. So, relying on those experiences and even things that happened more recently are easier and come to mind more often. It's also you tend to stick to that first thing that you may think of in terms of experiences. Let's take a step back and think about all of the projects that we've been part of and that experience. The base rate fallacy is failure to consider relevant statistical data or base rates when making those judgments and experiences. And it falls in line with that availability and the hindsight biases, that you're not going to consider everything that you may be aware of. Good practice in terms of improving project importance and software estimates is tracking data over time. So when you do come into something that is similar and you avoid your uniqueness biases, you can say, okay, we've done this similar project before. We've developed a platform on Azure or AWS. We've connected in, with the security systems. But yeah, this base rate fallacy is really all around that. You don't want to ignore the information that you have. Anchoring is a tendency to rely too heavily on that first piece of information encountered. And this is very closely tied to that availability bias, where the first thing you think of, you're going to anchor your experience around this. This is used heavily too in marketing, where they're going to give you that first price and tell you, hey, this product is worth, $1,000, and then, but we're going to discount it down, to $300. You're latching on to that idea that it was $1,000. So it really is going to influence your thinking and the way you make those estimates and what you do with it. So, and then you're also, because you're familiar with that first thing and you're really tying to that, you're going to look for information that confirms that thought. So, okay, we think this is the estimate. Okay, what other factors should we consider to be able to help adjust our thinking and not rely too heavily on that first piece of information that you may have come across? Escalation of commitment then is, again, it's a big part of human nature, but once you've made a decision, you become invested in it. Particularly, I'll say, as individuals rise up and into more senior positions, you need to defend your territory, to defend your decisions. Sometimes, that might not be the right approach, and you might need to take a step back and not win at all costs. So the idea of this is, and related, is the sunk cost fallacy. So even though we may have spent, $100,000 on this project, does it still make sense to consider, you should really look at the future effort for the project and not necessarily what was already spent. We spent $100,000 on the project, but to get it to completion, it's going to be another $300,000. Okay, so now is a good point in terms of thinking about that. Or are we going to escalate our commitment to this and continue on, which might potentially be a bad path? This idea also falls into helping, that availability bias. You're going to find stuff to confirm the idea that it makes sense to move forward. So think of those contrarian actions and thoughts that you might be able to apply to your decision-making process and estimating, the next task, the next project that you're going to be part of. So we look at the problem. There's a bunch of different things, the optimism, uniqueness, and there's a lot of overlap between these, but that is very much tied to the idea of memory in what we remember. So the more you can track information across time, the better off you're going to be. So what is the solution? Is it awareness? Okay, so now that we've discussed, the idea of hindsight and availability, and that you're going to anchor your decisions around a particular idea, and there's tons of literature that has been written on this. Well worth your time to go out and do some Googling or talk to ChatGPT, about these different biases and how to avoid them. Is being aware of them a solution? Well, interestingly, in the research, awareness is not necessarily a solution. Even though you are aware of these things, we as humans tend to still have biases in these directions. So it's something that you have to actively work on and make awareness. At Estenda, our software development process is very much around the idea of checklists and things like that to help us remember these things. But don't throw in the proverbial towel. I think there is still good ways of addressing and working at estimates that we're going to talk about here. We do need estimates, so there are, I think part of Agile and the idea of sprints as an industry, we've probably gotten a little away from the idea of estimating things. Yes, we talk about story points and how long that story point is going to take, or estimates in terms of t-shirt sizes and those types of things, which is a form of estimating. But it's important to know how much something's going to cost, how long it's going to take, even just for planning and decision making. You have to figure out your ROI on a project, whether you're a large organization. If you're going to invest $100,000, $1 million in a project, you need to have some concept of that cost to figure out what the ROI is. And this goes from senior level management down to the intern, the software developer, the QA person that's estimating their effort, even the requirements analyst, in terms of, okay, how long is it going to take to gather the necessary requirements to produce the documents? You need to manage the expectations so that everybody else that's part of their team can help make better decisions and align things. Ultimately, it's about getting stuff done. How many times have you asked outside of software development, even at home? It's like, okay, we need to get something done. We need to get a project done. I need to weed the garden. How much time do I need to plan to weed the garden and hope it doesn't rain like it is right now outside my window? That interferes with it. Interestingly, there's also a movement out there, you can Google this, it's the idea of no estimates. And I just don't think that's a good idea. We need those estimates to be able to make better decisions, manage expectations, and really get stuff done. Ultimately, better estimates lead to better decisions. And better estimates lead to better quality. This is an interesting concept as I was thinking about this presentation and what better estimates really mean. If you're not familiar with the diagram here, it's the project, triangle kind of thing. As you change any one, an equilateral triangle, if I remember my grade school geometry, as you change any one of these, it's going to have an impact on the other. As you change your resources, people involved on the project, the cost, the scope creep, we're all very familiar with that. Projects don't tend to remove features and functionality, definitely tend to add more features and functionality. So then that's going to impact your schedule and resources, and the overall quality of an application. There's something called the Parkinson laws, and again, these predate pretty much software development. You could probably make arguments as when did software development really start, but back in 1955, Parkinson's law states work expands to fill the time available for its completion. So if you think about an estimate where you have to do a particular task and you say it's going to take 2 weeks, well, if that developer finishes in a week and the testing happens and it has produced good quality, because they have that extra week, software developers, and I'm just as guilty as this as the other person over the years as I did my software development projects, you start tinkering. What else can I do? How else can I improve this? Let me make this one little change over here. And it might be good, but it has a bigger impact to the project. So you might change something, but okay, now this has to be tested. Does it change the requirements? So then there's documentation changes around it. Do you clearly communicate that you even change that such that it can be tested? So if you estimate too much time, interestingly, your quality could also decline. If you don't estimate enough time, then what tends to fall down is that quality. That's where shortcuts tend to be made, unfortunately. This goes back to 1908, so even further back in time, but I think this applies to everything we do in terms of software development. A person is most productive when they have just the right amount of stress pushing them, not too much, not too little. Stress is good. It improves you. I think it's true for software development, for physical activity, for training. If you're doing strength training or working on running a 5K, you want to stress the body just a little bit. So you want to stress the mind just enough. And if we look at this from a level of stress perspective, if that estimates are, very generous, then you're in this low zone, and that's where that developer, the individual can be a little bored and start tinkering with something else that maybe they shouldn't be touching. But if you're on the high end of this and experiencing a lot of stress, that's where we get into issues, anxiety, breakdown, burnout. We always strive to avoid this side of things of stress and accurately plan. So the better your estimates can be, the better off you're going to be. So as much as you can stay in this optimal zone where it's around growth and learning and pushing just enough, hitting that sweet spot there, the better off your project's going to be, the better off the team's going to be, and experiencing growth and learning. So how do we do better estimate? Beyond just thinking about those biases and actively thinking about them, what can we do? I think first and foremost is do the estimating. Oftentimes, projects come along, even whether it's a big project that's, many tasks, or within a project that customer manager asks for an extra feature to be added. It is really about, let's sit down, think about this, and do the estimating. Pick a method. There are tons of methods out there. You can, top down, bottom up, t-shirt estimates, story point estimates. We have various spreadsheets that we use to do our estimating and apply risk factors to it. But really, it's pick a method, become familiar with it over time and use it. In my opinion, I don't think any are better or worse than the other. It's about using it. If you do have the luxury of time, how do you use one or more of those estimates and see how they might come together, or are they really far apart? So, early on, you start down with a top-down estimating technique, a very high level. Okay, we need to include, this is bound by HIPAA, so we need to include security, or it's going to go through FDA review. Okay, that's going to add a lot of overhead to the project. Or you can start from the bottom up, where very fine-grained details, I got to write these 25 functions, and see how those estimates come together. I mentioned checklists, and I think this is hugely important when you're estimating to help avoid those biases. Make sure that you're considering all of the factors that you need to consider. In your performance, what is it? What are the performance expectations around creating that particular feature for your user requirements? If you're early on, okay, we're not going to consider performance, but you've thought about it at least. You didn't forget about it. When we talk about the availability biases, maybe you just don't think about performance early on. Or as a software developer, it's like, okay, this has to go through, quality assurance and the testing, and okay, I can do this in 2 days. Great. Well, now, the person that's responsible for testing, that testing effort where it might have taken you 2 days might take a week to test, depending on what the features and functionality is. So, how can we use checklists to help make better decisions? And I should probably change this to use instead of just use historical data, make sure you're tracking that historical data. How do you remember from this information over time? This helps avoid those biases that we're talking about. When you think about your availability, it's like, okay, I'm going to remember my last project, but what about the project that was done, a year ago? It might apply more specifically to your experience, but try to avoid that uniqueness bias. You want to make sure that you're not discounting something. And of course, remember those biases. Maybe make a checklist of the biases and say, okay, how are we addressing each of these? And then also, it's not in specifically call it out here, but as a team, so picking your method and using one or more, have 2 different team members, again, based on the luxury of time that you may or may not have, have 2 different individuals estimate a project, come together, discuss, the differences and how to make the best decisions. Beyond the individual task and estimating that individual task and individual projects, I think there's some things that can help as an organization or just as a project team can help you do better. First is really understanding the concepts of risk management. So if you're taking on a project that is new to the team that they don't have experience with, okay, those estimates are going to take longer. What is the experience of the team? Do you have a team of software developers that are very intimately familiar with the software programming language you're using, the domain space, the cloud platform, the database you're using, or is this your first time doing something in Azure or a specific type of architecture? One of the things that comes in here a lot is the idea of applying new technologies to a problem. And there's an adage of there is no silver bullet. So as you're being challenged in a software project, software developers, in my experience, will often be like, hey, if we migrate to solution X, programming language X, this will solve all the problems. Well, that's where the second comes in. There's a bunch of unknown things. When you're bringing on that new technology, maybe new to the industry, programming language Go came about. There's a bunch of people that have experience with it now, but in those early stages, people were just trying to figure out, okay, what were the boundaries and limitations of the programming language Go? People didn't know what they didn't know. So how do you find and identify those things earlier on in the process to help make your estimates better? I think we need to always focus on adding value. So making sure you're doing those estimates. Does it even make sense to do a particular feature? What does that mean? And then ultimately fostering the culture of accountability. when people are open and honest, and you can have a good debate about the requirements, the estimates, what needs to be done, the better off you're going to be. Along the same lines, setting clear goals, clear expectations. What is this project, or this task within the project? What is the goal that needs to be accomplished? Don't over-engineer based on your goals, and work towards those better requirements. What are the unknown things? What do we have to figure out and discover? If you have the luxury in a project, how do you start with very low fidelity, low level, detailed, wireframe documents to talk about things, and then increase the fidelity or specificity of what you're looking at, what you're working with the customers. This is the idea around Agile, gradually building something up. If you think historically of the waterfall method, we used to all sit down and plan out a project that was going to take 30 years. Well, even in the first month, that project schedule was probably not accurate anymore, because you start learning a lot of stuff. And so, while you might not practice a specific form of Agile, Scrum, or XP or something like that, embrace the principles of Agile and help drive those better requirements. Along those lines, from an estimating perspective, it helps drive realistic schedules. It helps keep everybody in line. Effective communication is always good. User involvement, obviously, in the Agile world, very beneficial. The users know the most about their experience. Here at Ascenda, one of the things we try and do is, we work in healthcare. So if you work in diabetes or heart disease or, brain type of issues, we're going to provide some of that core training around the biology, around how do you care for a patient with diabetes. So the better you can understand the situation, the better off you're going to be. The more you can involve users, the better off you're going to be. And that is really around those requirements, because as they start seeing things, they might not even be aware of those unknown things. Like the user it might just be so much part of their daily living, they don't really think about it. So, if you have a good requirements analyst person, or doing user interviews, how do you pull and tease those ideas out to make sure that they're clearly communicated? And I think with estimating, embracing change, very much part of the Agile philosophy. Things change. So as you do your estimates kind of thing, it's okay, this project is, this task is going to take X number of days. Okay, you're going to get new information that might impact that estimate. So, communicate. Okay, we learned something new that has an impact on the change. And along those lines, you have to be aware too, and this sort of bleeds into project management, but as you get those number of small tasks, like, yeah, okay, this, it's easier to estimate kind of thing. This will be, a 4-hour change. Is anything really 4 hours? How much have you talked about it already to get to the understanding of what it is? Then you need to communicate to the developer. You have to communicate to the QA person. You have to do the documentation. How does it impact your rollout schedules? So really keep that into consideration as you estimate things. What is the full impact, not just to one individual on the project team, but the entire project team? And then in terms of estimating too, look at the task size and complexity. So when you are estimating, even in those early stages, it's like, if you estimate something is taking a month, okay, that task is probably too complicated. And so driving down to a smaller task size, less complexity, makes it easier to analyze, makes it easier to understand how those biases may come into play. And one of those biases, it does talk about your ability to control the situation. And if you have a really complex, large task here, how much control do you have around that, of the scope or how it needs to be implemented, or you're using a new technology, your complexity is going to be a lot higher. So the smaller you can estimate and drive down and manage task size, the better off you're going to be. And I alluded to this earlier. I think a part of estimating, which we need as an industry to strive towards, is changing the conversation. What I think of as changing the conversation. So there is, I've seen this in a variety of different fashions, but the cone of uncertainty around your estimates. So, as we're at the idea stage of something, of, okay, we're going to do a project. How long is that going to take? What are the odds that our estimate is actually right? And, is X. If we say it's going to cost $100,000, which means, we have 4 software developers and it's going to take 6 months, okay, that's the estimate kind of thing. But that's probably really not true at that point in time, because you're going to learn new things. So as the project progresses and you start getting into the requirements, start getting into construction, that cone of uncertainty is going to get narrower and narrower. As you learn more and more about the project, then you're going to have more certainty in that estimate. What you definitely don't want to happen is, have this estimate then start, curving up, as opposed to, getting down to a more accurate estimate. And then once you even get, as you get into delivery phase, as I was creating this graphic, I was like, does it ever really come down to the exact specific, because when you get into delivery, there might be things that you're not entirely sure or aware of, as that project might be bigger. So being aware of this is very important. And so in terms of changing the conversation, what very often happens, and I try and always avoid this trap, but from a deterministic perspective, someone talks about a project and a task, and they're like, okay, it's going to cost $100,000. But in those early stages, even halfway through a project, do you really have the level of knowledge, experience, information to be able to predict that? So we should change the conversation to one that's, I think, more about probability. So early on in that stage, okay, we think it's 70% chance it's going to cost between $80,000 and $120,000, and it's probably going to be more on the upper side. There is a 20% chance that it's going to cost even more, 10% chance that it's going to escalate and go beyond that. Interestingly, as we look at this last chart here, there was this area that the estimates might be massively overblown. I think because of scope creep, it tends to be more, estimates are increase rather than decrease. Hence, this is 4x and this is only 0.25. It does make a difference. Projects tend to increase rather than decrease. Hence, whereas I'm presenting this as okay, 70%. Based on our experience, time frame, using familiar technologies, we have a pretty good idea of where this project is going to wind up, but still not coming up with a specific cost number, giving yourself some wiggle room. And yeah, if there is significant scope creep, some unexpected things, those unknown things that we find, the project could escalate, kind of thing. As a good software project, project management kind of thing, you always want to have a contingency fund, but this helps you put that into perspective. And ultimately, Agile embraced the idea of retrospectives, but I think the important thing is around this is just we want to learn from our experience. So the more you use a system to track information, and what your tasks were, what your estimates were, how long did it actually take you to do that task? How do we learn from our experience and talk about it as a team? What did you miss? But also, what did we do really well on this project? How can we make it better, next time around? That idea of reflection also helps those biases. when you talk about that hindsight, it's like, okay, you do want to be careful of like, hey, avoiding blame and understanding that you didn't have perfect knowledge going into the project. So don't, you don't want to forget about that. But it helps you better understand things as you move forward. And if you track this information such that you can go back and reference it over time, all the better. With that, that is my presentation on estimating. Just thank you for your time and attention. We'll go to questions in a minute here. I just wanted to call attention. I posted just yesterday. We do have a new presentation coming up, driving quality in digital health, the role of AI in testing. We'll do this in middle of June kind of thing. We did do a presentation yesterday on using AI in product development. If you weren't there, I did see some familiar names of yesterday and today. We are going to make that available. So if you didn't attend yesterday and are interested in AI and use in product development, message us and we can send that to you as well. But this will be a new presentation using AI in testing. Thank you. Brian, any questions that I can help answer?
All right, thank you, RJ. Let's see, we've got a question here. It says, can you talk a bit more about how you account for scope creep, risk factors, and unknowns when doing estimates? Also, if applicable, the balance, sorry, it's scrolling. The balance of cost versus value when estimating for clients.
You'll have to remind me to come back to that second question. But for the first one, in terms of thinking about scope creep and those unknown things, as we have a spreadsheet, and as we're estimating, those individual tasks, and I'm coming up with costs for a project, I definitely, task, and then I have columns for the various different areas that may be applicable, front end, back end, cloud costs, QA costs, and those types of things. But then I apply a risk factor to each of those individual tasks such that, how sure am I of this? What is our experience with this? And assign a risk factor to it. So even though as we calculate things out and say, from a front end experience, this is a small project, or this is a medium project, or this is, a high project, those estimates are going to have specific values, and then I can apply a risk factor. We've never done this before. Client's not too sure what we want. We're going to apply a high risk factor to it, and which then, multiplies it by 2. And that's the estimate then to apply for those unknown unknowns. Or if it's something we've really done multiple times, a project team's familiar with the functionality, client has clear expectations, then my risk factor is going to be a lot lower on that. And we're not going to multiply the estimate by 2. But part of what we do too to help avoid those biases is just have it be very well structured and somewhat take the human element out of the individual value for that. So I hope that helps. What was that second question?
It said also, if applicable, the balance of cost versus value when estimating for clients.
Cost versus value. Yeah, I think the estimates help drive that. So where the cost, whether it's $10 or $1 million for a particular project, as a team doing the software development, understanding what value that brings to the client is an important factor. So, and what is that ROI? So even though if something costs $1 million to develop, if the value to that client is 2x that, hey, it may still be worth doing. You are taking on more risk, so you have to be aware of that. And what does it take to deliver a $1 million project versus a $10 feature in that? So you do have to balance that. And the more you understand the situation as you're doing those estimates, the better off you'll be.